Welcome to the first of many videos that I'll be recording throughout the semester to explain fundamental concepts that we'll be talking about in class. We'll start at the beginning with structure and bonding. First I'll describe ionic and covalent bonds and then Lewis dot structures. First let's start with defining what organic chemistry is. As many of you already know, organic chemistry will be the study of carbon. Carbon is what underlies all living things, organic things. Carbon primarily bonds to other nonmetals, mostly nitrogen, oxygen, phosphorus, sulfur, fluorine, chlorine, bromine, and iodine, so we'll be staying in the top right corner of the periodic table for the most part. Remember that when nonmetals bond with other nonmetals, you form covalent bonds. So in organic chemistry, mostly we're going to be talking about covalent bonds. If two nonmetals, in this case atom 1 and atom 2, bond to each other, they share electrons in a covalent bond. A simple example of the sharing of two electrons would be hydrogen gas. In an ionic bond, an electron is transferred from one atom to another. This atom becomes positively charged. Since it's lacking an electron, this atom becomes negatively charged. And those positive and negative charges attract one another in an ionic bond. Sodium chloride is a good example of an ionic compound. So how would we depict these bonds in molecules? Well, remember, hydrogen atom is simply a proton with one electron. So if two hydrogen atoms come close to one another, they can share these two electrons in a covalent bond, which we're going to depict in one of several different ways. We can draw like this. So these two electrons are a covalent bond between the two hydrogens, or we can just draw a line which represents the covalent bond between the two hydrogens. This is a covalent bond here. As opposed to a covalent bond, we can also depict ionic bonds. Remember the Lewis dot structure for sodium. Sodium has one valence electron. Lewis dot structure for chlorine atom. Chlorine atom has 7 valence electrons. And remember, according to the octet rule, an atom wants to be surrounded by 8 electrons. If chlorine takes this electron away from sodium, chlorine will be surrounded by 8 electrons and have a full octet. It will be happy. So sodium gives up that electron. Get a cationic sodium atom. Chlorine gains an electron. You have a negatively charged chlorine ion, and you have an ionic bond between the positively charged sodium cation and the negatively charged chlorine anion. In order to draw Lewis dot structures, we're going to need to be able to count valence electrons, and this is very easy to do with the help of the periodic table. You just need to determine what column that you're in. If you're in the first column, you're going to have one valence electron. Hydrogen, lithium, sodium, potassium all have one valence electron. Valence electrons are the electrons that are available for bonding, and it's essentially all the electrons past your core electrons, which are the number of electrons in your previous noble gas. These all have one valence electron. These all have 2. We're going to pretty much completely ignore the transition metals. This column has 3 valence electrons. This column has 4 valence electrons. This column has 5. This column has 6. This column has 7. We're going to ignore these guys. So it's very easy to generate a Lewis dot structure of an atom. We just need to know the number of valence electrons. So for example, if we start with lithium, it's in the first column, so it will have one valence electron. We go to beryllium, 1, 2, it's in the second column. Boron is in the third column, so it has 1, 2, 3 valence electrons. Carbon is in the fourth column, so it has 1, 2, 3, 4 valence electrons. So these would be the Lewis dot structures of the first 4 elements in the second row. When we get to nitrogen, we have 5 valence electrons, and then we need to start pairing those. So in nitrogen, you're going to have 1, 2, 3, 4, 5. So you have a lone pair of electrons and 3 unpaired electrons. In oxygen, you have 1, 2, 3, 4, 5, 6. So you have 2 lone pairs of electrons and 2 unpaired electrons. And finally, for fluorine, you have 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. Notice now you have one unpaired electron and 3 lone pairs of electrons. You want to pay attention to how many unpaired electrons each atom has, because typically the number of unpaired electrons is going to be the number of bonds that atom is going to make if it's neutrally charged. So neutrally charged carbon makes 4 bonds, neutrally charged nitrogen makes 3, neutrally charged oxygen makes 2, and neutrally charged fluorine typically makes 1 bond. We're going to use the atomic Lewis dot structures to draw Lewis dot structures of molecules, and we're going to follow these 3 steps. In order to do it, first draw the molecular skeleton, or the arrangement in which the atoms are bonded to one another. Next, count your valence electrons and then distribute those according to the octet rule. Remember, that means that each atom wants to be surrounded by 8 electrons, except for hydrogen, which wants 2. So let's say we're going to draw the Lewis dot structure of a simple organic molecule like methane, CH4. Carbon has 4 valence electrons and 4 unpaired electrons, so it's typically going to make 4 bonds. Hydrogen has 1 valence electron and 1 unpaired electron, so it typically makes 1 bond. So most likely, our molecular skeleton is going to look like this. Carbon is going to be making 4 bonds, so our 4 hydrogens. Carbon's going to be making 4 bonds. Each hydrogen is going to be making 1 bond. Now let's count our valence electrons. Carbon is in the 4th column, so there's 4 valence electrons. Each hydrogen has 4, so we have 8 total electrons. If we distribute those according to the octet rule, we'll surround carbon with 8, and each hydrogen will be surrounded by 2, 1, 2, 3, 4, 5, 6, 7, 8. Notice carbon is surrounded by 8 electrons, and each hydrogen is surrounded by 2, so everyone's happy. Everyone has a full octet of electrons. We can also draw this each 2 electrons shared between 2 atoms as a bond, so we can depict those 2 electrons as a bond instead of a lone pair of electrons. This is sometimes a little bit easier or less messy. So those are 2 different ways to draw the Lewis dot structure of methane. This is the way they show it in the book. You have your carbon atom, you have your 4 hydrogen atoms, those combine to get the Lewis dot structure of methane. Okay. Let's do some more difficult examples. Remember step 1, draw your molecular skeleton. You have your carbon atom. It's going to be making 4 bonds, 3 of which are going to be to these 3 hydrogens in the formula, 1 of which to the oxygen, and the oxygen is going to be bonded to a hydrogen. Remember, carbon has 4 unpaired electrons, it makes 4 bonds. Oxygen has 2 unpaired electrons, so it's making 2 bonds, 1 to carbon, 1 to hydrogen. Now we count our valence electrons. We have 4 from carbon, 3 from hydrogen, 6 from oxygen, 1 from hydrogen. Remember, this is in the 4th column, this is in the 6th column, hydrogen's in the 1st column. The total we have here is 14 electrons. So now let's distribute those according to the octet rule. We'll surround this carbon with 8 electrons. That's 1, 2, 3, 4, 5, 6, 7, 8. We'll surround the oxygen 1, 2, 3, 4, 5, 6, 7, 8. We have 2, 4, 6, 8, 10, 12, 14. Everybody's happy. Everybody has a full octet. So this is going to be our Lewis dot structure. We can also use bonds instead to make this a little bit cleaner. So we have a bond between each carbon and each hydrogen. We have a bond to the oxygen, a bond to the hydrogen, and then the oxygen has 2 lone pairs of electrons, like so. So that would be methanol. The next one is formaldehyde. Notice that we're going to have a little bit of a problem here. We have carbon. Carbon is bonded to 2 hydrogens and an oxygen. Remember I said that the number of unpaired electrons is usually the number of bonds, right? It looks initially like we might have 3 bonds. Carbon likes to make 4 bonds if it's neutrally charged. So notice right away, if we count our valence electrons, we have 4 from the carbon, 2 from hydrogen, 6 from oxygen, that's 12. If we surround oxygen with 1, 2, 3, 4, 5, 6, 7, 8, and we surround carbon with 8, 1, 2, 3, 4, 5, 6, 7, 8. We'll have too many electrons. There's 2, 4, 6, 8. 2, 4, 6, 8, 10, 12, 14. We only have 12 to work with. So let's try again. Carbon, oxygen, hydrogen, hydrogen. But now let's share more electrons between carbon and oxygen. If we share 4 electrons between these guys, now carbon has 8 electrons. Oxygen has 8 electrons. We have 2, 4, 6, 8, 10, 12. So there's a double bond between carbon and oxygen. If we don't have enough valence electrons, that is going to be a clue that we need to start forming double bonds. Okay, so to review, what we talked about is bonds. Primarily in this class, we're going to be focusing on covalent bonds, which are those shared between two nonmetals. We want to be able to count valence electrons, and in order to do that, just look at the periodic table and figure out how many or what column that the element is in, and then use the number of valence electrons to generate Lewis dot structures for molecules, remembering that typically the number of unpaired electrons is going to be the number of bonds that the uncharged atom is going to make.